Salam sejahtera and good afternoon to all of you. Welcome to today's sections. My name is Desmond Lim. We are from OEMS Intipakar Corporations, Sdn Bhd. Our company is the only certified and Wolfram partner in Malaysia that we actually doing the consultations, trainings, and the license distribution for the local community. So like today, the trainings is our frequent activities. We are conducting a lot of online training and also on-site training as well for local university and community from time to times. And as you can see, today's sections, our topic is a quick start to Wolfram language, which is suitable and designed for the beginner of Wolfram Mathematica, that you want to get to know how this software can be big benefit to your works or to your project or to your assignment or your studies. Okay, my name is Desmond Lim, and together with me is Mr. Peter Lim. He will be a coordinate for today's section on the chat room, also on Q&A, and I will be the one that actually presenting for these 3-hour sections. So if you have any questions, please feel free to put in the chat room or in the Q&A. We will go through with you from time to time. And also, I already post the link for today's materials, which we were using it for today's trainings. And we also want you to also go through with me together so that you can practice all the example and also the coding, so you will get familiar with it after the training as well. Right? So let me share my screen again. Okay, this is the slide or the material, the only file that we are be using throughout today's sections. So if you have any questions later on after the workshop, after the training, you can always refer back to these materials. This material is filed in a format called .mb file, which is open with the Wolfram Mathematica or Wolfram language. So if you have not installed the Wolfram Mathematica on your PC, or if you have no access to the Wolfram Cloud today, no worry, you still can go through with us later on after you are successful install your license, and then you can try on with this notebook file again. Okay, this is the link. I put it again in the chat room so that you can download. Right, it's in the chat room now. And today's we have about 100 people registered for the sections, for these 3-hour sections. But as normal, as there will be some people couldn't make it at the last minute, so we probably have, I would say probably 70% or 65% of you will turn up. But that's okay. We also will have today's section recorded. If any of you would like to have the recording sections, please write to us either through the WhatsApp that you will receive the message from us, or you can go through the email writing to us to request for the download recording. And today will be a certificate of attendance available for all of you at the end of today's sections. By the end of the sections, I will give you for a link to request your e-certificate as well. All right. Okay. Before we get started, maybe I want to hear something from you all so that I have a better idea your experience with the Wolfram Mathematica or Wolfram language. If any of you are using the first time or you have no experience with Wolfram Mathematica before, can you type 0 in the chat room so that I can have a roughly idea how many of you are totally new with this software? If you are no experience with this, or you heard of it but you haven't tried before, and today is the first time, probably try 0 in the chat room. Quite of you, okay, thank you. Ellen, Ching, Avina, Edith, Rick, Nusafika, Asfar. Okay, it's quite of many of you. Uma have some experience. Said also have some experience. Okay, that's fine, that's fine, that's good. No problems. We will go through with you a step by step in a slower pace. If I'm going too fast, you can also raise your hand or you can voice up to let me know. But of course, 3 hours looks like quite some time frame for us to go through everything. But in fact, there are a lot of things to include for today's sessions. So we might not be able to complete the whole material today, but it's okay. We will have all those step put in the material itself. Even you go through by yourself, it should be able to make some sense from all of it. But if you have been questions after the sections, you are most welcome to reach us. All right. Okay. If you click on this link, if you haven't downloaded yet, I will show you how you get today's material. Some of you may have the desktop version, the Wolfram Mathematica install. Some of you may not install yet, but if you have the Wolfram Cloud versions, or if you have the Wolfram Cloud license, especially those from the University Malaya, you can access to the cloud versions. So you also can follow today's section through the cloud versions. There will be some minor difference between the desktop version and cloud versions, which some of the function used in the desktop might not be available in the cloud, but it's just a very small portion. It shouldn't affect your interactive or your experience with the Wolfram language. So if you click on this link or if you screenshot URL, scan this URL, it will bring you to this page, the Wolfram Cloud page. Okay. Whether you have the cloud license or not, you also will access it in the cloud. Okay. Only difference is if you have the cloud license, you can interact and do some computations on it. If you don't have the cloud license, you can still view all the materials with limited computations, but it have no it won't stop you from viewing it. It just like looks like a PDF file, but you cannot do the calculations. Okay, this is the copy I share with you. But before that, you start with today's sections. I would like you to click on the make your own copy button here. Okay, when you click make your own copy, you actually open in your cloud versions. If you have a desktop versions, you just click download. Download this whole file. The file name will be called quick start WL Wolfram language _ 2024.mb file. So you can click download this file and then you can modify and play around with all the material today. Okay, it's two methods. If you have a cloud versions, cloud license, you can just click make your own copy and then access through your cloud versions. Or most of you probably you need to click download it, download to the local, and then double click it to open with the Wolfram Mathematica, right? If you haven't do it, you can do it now. I give you probably a few minutes so that you can download material and then launch this file together with me, right? Okay, I will share the link again in the chat room because some of you probably have missed it. So I just post in the chat room again. You can click on the link, or if you are using mobile, you probably can scan the QR code here as well, right? Okay, I assume you have no problem to open this file. This is the first page. Wolfram Mathematica is a software that you can have everything under one roof. So even with a presentation file or a computation file, everything can be inside here. So I can use my file to do it as a presentations, or I can do it as an ebook, or can publish it as a report as well. So it's everything inside one file. You don't need to convert from the Word or convert to the PPT or convert to Excel. Everything inside here. They have all the feature that you need for all these functions. So I'm using the same file for presentation as well as for today's computations, right? So I assume you already done this. We will go to the next slide, the slide, 2 out of 25. If you have noticed at the top left here, it's like 2 out of 25. Okay, right now, I myself is already inside the Wolfram Mathematica software. So if you are first time launching it, you probably will see this welcome page. Let me show you the welcome page. So when you first time launching the Wolfram Mathematica, you will see the page like this. Okay, you have the welcome page say Mathematica for desktop versions. Right now, I'm using the version 14.1, the latest versions from Mathematica. It's okay if you are not using these latest versions. Most of the feature is still the same for today's sections. Only some of it that in the latest versions, maybe you don't have yet, but it's okay. It still be all right to follow through. Okay. Only that the file, because I'm created with the 14.1, if you are open with the previous version, you form out to show you, to tell you that this file is created with the latest version, newer than yours one. Is that okay to open? Just accept it, they will do. Right? So this is a welcome page. Once you in the welcome page, you can open up your file, whether new document, or you can just open your new file or any recent file, open from the cloud or open from local. Okay, so the second slide, the Mathematica and the Wolfram language. Okay, I want to put this in at the front is because people might confuse between what is Mathematica and why is the sometimes we say Wolfram language. Actually, Mathematica is the tools, the software that we are using right now. It's a tools or software or program for symbolic computations, widely used in the STEM, maths, science, technology, computing, finance, even all kind of computations. Okay, it's a flagship products, and it have a desktop version, also a cloud versions. It have been in the market for more than 35 years, close to 40 years already. All right. And when we talk about the Wolfram language, what is this Wolfram language about? Wolfram language is actually the language that run the Wolfram Mathematica. Okay, it's a name for the programming language. Why you want to separate it? Because Wolfram language is also using on other product beside Mathematica, such as Wolfram Alpha, Wolfram Engine, Wolfram Cloud, Wolfram One, because Wolframs have other product as well, but they are using the same language called Wolfram language, whereas Mathematica is one of the software or program. Okay, but today we are using Mathematica and we are learning the Wolfram language. So both things can be interchanged as well, right? I hope that don't confuse you, right? So as I told you earlier, we are using 14.1 for today's trainings. And starting from a 14.1, this latest version that launched, I think just released maybe 1 or 2 weeks ago, you will see Mathematica have put everything under an application called Wolframs. So starting from this version, all the Mathematica, Wolfram Alpha notebook editions, Wolfram One or finance platform, all those tools will be under a same root called Wolfram application, Wolfram app. So when you download and install the first time for this software, you will see it asks you to download Wolfram. It's not saying that download Mathematica, it's saying download Wolfram because it's become one applications. And depend on how many license you have for this different feature. Maybe some of you have Mathematica license and also with the Wolfram Alpha Notebook editions. Then inside this Wolfram app, you show the available license that you have. If you only have Mathematica, then under this Wolfram app, you only will see Mathematica. If you have all these different licenses within the Wolfram app, then you actually can switch or change in between these different applications. Okay, where to see all those things, you can go to the edit, the top menu here, and then check on the preference. Okay, you don't need to do anything of it. I just want to let you know about this thing so that later on you have some idea why it's called Wolfram, especially for those people who have been with Wolfram Mathematica for many years. Suddenly the name, it changed from Mathematica to Wolfram. They will be confusing. As you can see under the Wolfram application right now, I have different product called Mathematica or Wolfram One, and just select whichever license you are using right now. You just switch to the license that you are using, right? Okay, but it's okay if you only have Wolfram Mathematica, then you don't need to worry or don't need to concern too much on this. All right. Besides, we know about Wolfram, that who is using the Wolfram Mathematica or Wolfram language. Okay, I would say all the world top university actually they are using Mathematica. All right, and locally we are USM, University of Science Malaysia, or University of Malaya, or Monash University. They not only having the license, but actually they have a full campus license. That means all the students, staff, lecturers from this campus, they are entitled to personal license, personal free access to the Wolfram Mathematica, and also Wolfram Cloud versions, especially for UM. They have also the cloud version as well. And Monash, they also have a cloud version, and they also have the Wolfram notebook edition as well. Okay. And some other university beside these three in Malaysia, they have smaller licenses group, like lab license or group license or individual research license. Those are some of the local university, they are using this. And for your information also, we have some other private industry, they are using Wolfram technology as well. Probably most of you are familiar with this company, but you don't know that they actually also using the technology. Okay? For local, we have the Daikin, CMB, Hoya, Mimos, Selamager, Technique, all those, they are also using the Wolfram technologies. Okay, if we are new with the Wolfram Mathematica, what is this Wolfram Mathematica and what other people usually say about this? Okay, you will say, okay, most likely people will say, okay, this is a powerful symbolic and numerical computation tool. Okay, why is it? You can see that if I click this one to open up, you also you have the file with you, so you can try to follow through this as well. You open this file and you come to this slide number 5. You can just open up this drop down, and then you can see I actually purposely made some changes to the template. So I made the input line in the background of blue color. By default, it won't have this blue color in the background, but I purposely made it for every input, it will be in blue color, so easy for presentation, also for the training's purpose. Okay, as you can see, when this is blue color, is a computation cell, computable cell, compared to this line is a text line. This is all the text. Okay, they are not computable. But this one is computable, it's in blue color. I differentiate for you to have a look. So people say, okay, this is a powerful symbolic and numerical computation. Why is it? Because you can simply solve equations. Where this is the equation you want to solve in terms of x, you just put a wording, say solve. And then to run this computation, while my cursor is inside this blue cell, I press shift and enter at the same time, then you give me the result or the output. You can see this is the input number 2, this is output number 2. They are correspondent to this one. So the output 2 will be refer back to the input 2. So this is the result. And you can even solve multiple equations, okay, together, or more advanced computations, and then I shift enter, it gives me the output right away. Okay, this is how you can solve the numerical and symbolic computations. And you also compute symbolic input and output. People say, why is it? Because even in the format of the like the textbook mathematics, with the symbols, with all this, with the infinity, with the limit, all these symbols, Wolfram Mathematica or Wolfram language, they know, they recognize, and they are able to compute based on this input as well. So even with this kind of format, if I shift enter right now, it actually do the computations. Okay, this is the first time, so you ask me want to evaluate the input. I click yes or click always, then you know, okay, this is the output. The answer is pi. Okay. So not to worry if you have say if your versions or maybe your input is like in a traditional textbook type, they can recognize. Okay, how to change this one? In fact, by default, it's not showing like this. I purposely made the output or the appearance in this traditional mathematics format. In fact, I just convert it. If not, I can just right click on this cell, the whole bracket here and the right hand side. Okay, right click on it. I just click convert to what? Standard form. This is a standard input form is like this. Okay, this is standard form. So just now I just click and convert to traditional form. Then it looks like a textbook format or LaTeX format. Okay, otherwise we will use back to the standard format. Okay, it's the same whether this format is traditional or standard. You do the computation as well. So for this limit, you can also do the computations. Right? The answer is negative infinity. So not only it recognized all this symbolic input output, it also made the interactive visualization very easy. I can easily create a sine omega t plus phi. Okay, give a graphic of this one, and also I want it to be interactive. So I just press Shift Enter in this input line. I'll get a visual like this, with the omega can be changed, and also the phi value can be changed. I can have this interactive GUL. Okay, you can easily create this one just with one line of coding. This is the coding, one line only. Okay. As you can see, when I navigate between this one, the bracket on the right hand side actually is represent the cell. The cell, it could be one row or it could be multiple row. So for this one, where I click right now, it looks like the blue line is one row. But if I enlarge it, make it larger, it becomes two row as well. But whether it's one row, two row, or 10 row, it's still considered one single cell if it's only under one bracket. It is considered one cell. And this one, another cell. Okay. To copy the whole things or to remove this, you just need to highlight the cell and then right click. Let's say I want to remove this output. I don't want anymore. I just click cut. Or if I right click on it and then I just press delete, you remove the whole thing. Or I can copy the whole cell and then go to a new place and then paste back. So it will be paste, copy, and paste. So you can interact like normal software, just that by selecting the bracket here, right? And then also people will say, okay, this Wolfram Mathematica, they are extensively multidisciplinary application. What does that mean? You click on this one. Mathematica has more than 6,000 built-in functions. Okay, we have a lot of functions which I cannot remember of. That is not possible. And this function cover all area of technical computing, everything under one single system. So what are those functions and what is available? If you want to find out more, you just go to help here. Click on the documentation, the first one, Wolfram documentations. Okay, this is the documentation. It shows all the main categories that are available for this Wolfram system. Okay, whether we want to deal with the language structures, data manipulate, analysis, visualization, graphics, image, graph and networks. If you are dealing with string or linguistic or text, if I want to deal with the geometry, I can click inside all this category to find out more. For this, like, let's say visualization and graphics. I can click on this one, and then show me, okay, under visualizations and graphics, if I want to further go into find out to visualize data, or I want to do geographic visualizations, which maybe you involve a lot of geographic output, and maybe you want to do some interactive drawing, or you want to deal with some dynamic visualizations, you can further click in. Or maybe I click on this one, symbolic and numerical computations, all kind of mathematics calculation like equation solving, calculus, optimizations, probability statistic, discrete math, Boolean computation is all available inside here. let's say you go to the visualization, let you see what is this documentation works, okay? If I want to find out about this visualization thing, I can click on data visualization for the first one. This is one of the first main topic under the visualizations, then come to data. And then say under the data visualizations, those are some of the available functions, the built-in functions for this data. So you can see there will be this plot, this line plot, this step plot, and the purpose of or the function of using this plot. Okay, and they also have list plot 3D, how to plot a 3D from the data, and we can also have a density plot, control plot, density plot 3D, control plot 3D, and so on, and array plot, and further down, there'll be, let's say we are building the data for date and time visualizations, you get the date list plot. Also, vector visualizations. And if you want to deal with all the charting, or the histogram, or different gauge, and some other visualization as well. All those are built in, and we can easily come in here and find out how to use those visualizations. You can see even got an anatomy visualizations, anatomy plot 3D. If you further click on this one, when you mouse over, you see it highlighted, means you can further click in to see the documentations about this function, anatomy plot 3D. Once you come in, they'll show you a lot of detailed options and an example. For instance, like anatomy plot 3D for the left female. Okay, this is how it looks like. And you can have other visualization as well. Okay. All those are available built-in in the Wolfram documentation or Wolfram language. Right? We'll come back to these documentations when we have time later on. But I just want you to keep in mind where to access this, because this is where we always come back and refer to, because somehow maybe some of you want to refer to for image, or maybe you want to do with signal processing, video processing, or you want to deal with geometric regions, math space, or geometric property solver, or some other, maybe you want to find out all the socioeconomic data. You want to find out the weather data live right now, or in the past 10 years, 20 years, or you want to find out some medical data, earth science, astronomical science, or some time-related computations, all is available under here. This is some important area that we always come back to refer, right? Okay, keep this in mind, but we'll stop for this one at this moment. We'll come back to our screen. So this is how people always say what is available and how people say about Wolfram Mathematica. Not only that we have these features, but we have a well-established community. Okay, if you go to the community, which can be accessed through help here, there's under Wolfram website. They don't have a direct link here, but it's okay. You can go to the any browser, just type Wolfram community. I think it probably is on the welcome page. I can't recall where is it. Okay, let me go to welcome page. Community is here. Okay, you can just click on the community here to access this page. Okay, you can see under the community, there are so many different discussion or focus groups, okay, on different topics. I believe there will be some topic relevant to you. Definitely you can find here. Whether you are dealing with physics, or maybe material science, or maybe you are dealing with education, technology, or some other, maybe you want to deal with data science, finance, or machine learning, or maybe some algebra, 3D printing, social science, astronomy, engineering, AI, quantum computing, calculus, business analytics, aerospace engineering, and so on. There are so many different groups available in the community. Okay, probably if you have questions when you're doing some project, you start there, or maybe you can come here to the community and shoot your questions. There will be some expert on the community that are very willing to help us with our problem as well. Or maybe the question we have, people have been asked before in the community, then you can find your solution there as well. Right? This is the community of Wolfram language. Now, let us start exercise our finger, do some simple calculations so that you can experience it firsthand. Okay, with this simple calculations, you can see that this is the page that I mentioned before that I already do some modification to the template. But when you first launch an empty or new file in the notebook, you go to File, New, Notebook. If you click on it, it's just an empty space like this with a horizontal gray line. We call the input line. And then you can see there will be a cursor blinking at the input line here. With the left here is a button. You can select whether by default is the Wolfram language input, the coding input, or you can use other input, maybe like freeform input, which I will show you later on. And also, if you want to input as a text, you can click plain text, or maybe you want to input it as a title, sections title, you can click other style of text. So if I click on other style of text, then it pop out a menu for me to select what kind of input is this. So I can select, okay, I want to input as a title. Then you, by default, this is a title font and the color. And I can select, let's say I want to go for the sections. This is the sections look like. And if I want to go for maybe item, means it's a bullet, okay? Or maybe item number. Depending on what kind of input I want, I can select, pre-select before I key in something. Maybe the item number, that will be 1, 2, 3, 4, depending on my input. So this is how we input something here. So to start input, when you see the cursor is blinking, that means we are able to key in something. So how to call out this input line, especially if you already have something on the screen, not an empty one. So you can see that this is the bracket for the cell. When I select this one, if you notice at the top left here, you told me the cell style is called sections. Means when I highlight this one is sections. If I highlight this one is called text. Okay, if I highlight the blue one, the bracket, the cell style here, you say this is a standard input cell. Okay, so this is the difference with different purpose. And how to key in a new input line. When I move my cursor, if you can see my cursor right now on the top right, if I move my cursor from the cell here, in between cell, then my cursor will be from the vertical I-beam become horizontal I-beam. When it become horizontal means I can left button mouse click it to insert the input line. Okay, see again, if I come here, I cannot click anything to input a line, but in between this bracket and this bracket on the left hand side here, in between on it, if I put my cursor in between, it becomes horizontal, then I click on it, then you insert a new input line. And now I can key in something. So for example, this one is an input line. I already have 4, 5, 6 times 2, okay? You can put your cursor or mouse anywhere inside this cell or the blue color, and then shift enter, you will get your output. The answer is 912, okay? And also, if I go to the next one, I straight away jump to this input line, 12454 with the power of 123. Shift enter, I get my output. Some of you may notice that, okay, Desmond, your input here show input bracket 9, output bracket 9. My one is different from you. So what is that means? Actually, the numbering here for the input and output is for the reference within the same sections. Once I close this file and open again, all this numbering will be gone. You appear in a single sections so that the programs know which output is referred to which input and how to interchange it, how to link them together. But once you go out and close the thing, the numbering will be gone. When you start with a new section, it starts with the number 1, 2, 3 again. They won't have a similar numbering for the input or output in the single sections. Okay, so it's for a reference purpose. It doesn't matter how many of it, 999 or 9, it doesn't matter. Okay, it's just for a reference. And some of us, sometimes we like to insert our notes or our text within a compute cell or the input cell, because maybe I have some programs I have written, but some other people open up, they might not know what is this program or this coding about. Then you can insert something in between. Put in your notes, say, oh, this is for your calculation on what. So people will see it and they will know what is this about. And with this open bracket, star, close bracket, the software or Wolfram Mathematica would know that anything in between is just a text they will ignore for computations. Okay, it won't count for the calculations. So this is how we insert a text. Okay, we have tried some example here. Now I want you to key in something inside this pink color cell. Okay, just key in. When you put your cursor, see it's blinking right now, you just type 216 divided by 7 and then shift enter. You see, okay, Desmond, input and output seem like no change. Okay, this is the purpose of the Wolfram Mathematica symbolic computations. What symbolic computations is, they will keep the output value exact value. They won't give an approximate numerical output unless our input value is numerical. This one is exact value, so that no matter the iteration you calculate for 1,000 times, you won't lose your accuracy. But if you want to have a numerical output, then your input value must be something in numerical. Let's say I got the 216.0 divided by 7. If I shift enter again, it gives me the approximate output, 30.8571. So this is exactly how actually a powerful Wolfram Mathematica in symbolic computation. Okay, if we don't want it to lose a position, we must give something like that. But of course, with this output, we still can say, I want to change this to the numerical value. How? I'll show you later on, or if some of you can see, there will be a suggestion at the bottom here. It's just with one click, it change or automatic compute in a numerical output value. Okay, it become like that. But that is for another story. I don't want to confuse you right now. So this is how we compute this one. And I want to introduce something called a percentage symbol. Percentage symbol is to refer back to the last result we generate. Right now, my last result is output 14. Okay, you can see this one, 14 is 216 over 7. Okay, if I want to refer to this 14, I just shortcut. I put a percentage and then plus 20. If I run it, the automatic add in. Okay, because my 14 is a symbolic output, my output for 15 is also symbolic. Okay, if let's say, let me change it to numerical output. Let's say I change it to this, my 16 is my latest output. So this percentage is always referred to the last output, last result. So it will refer to this 30.8571 plus 20. If I run right now, it becomes 50.8571. So what if I go back to this input 17, I shift enter again, what will be the result? Yeah, it's right. It refers to the last output, 50.8571 plus 20. So it becomes 70.8571. The output is 18, is the last one. If I run again, 90.8571. Okay, this is how we call the last one. But beside that, always get the last result. I also have the options for you if you want to refer to certain output. So this one is how we use it with a percentage, follow with the output number. Then you refer to the output. Let's say I want to refer to output 16. So I just put percentage 16, okay, and then shift enter. You know that it's 25.8571. So if I run it again, shift enter, it always get back the same thing because it's always referred to output 16, which is this one. It never changed. Okay, it won't change because 16 is already fixed. Okay, this is how we use a percent and percent output. We refer to certain output numbers. So now we do some exercise. Quite some simple hands-on. So that will be 1.1 to 1.4. Okay, I want you to take a few minutes to do it and key in your answer inside this pink color cell, and then run it to see you get the output correctly. Okay, I give you maybe 3 minutes. Try to do it, and then we come up together. If you already done it and you get your answer correct, you can also type it in the chat room so that I know that you already done. Right? For the first one, multiply the number. It's very simple. Just multiply all the numbers 1, 3, 5, 7, 9, and type it here. Come, we do it quickly. Once you're done, put in the chat room. Oh yeah, I got one numbers from Uma, 945. Yes, I also got one for Shafika, 945, 945 for Hasfa. Good, that's good. So instead of giving me the output, the numbers, I want you to also give me the input as well, the coding. So this is how the coding for this question number 1. So get a 945. Okay, go ahead for the second one, 1.2. Once you're done, you just type in your coding here. Okay, I know it's very fast. Wow, you are the first one. Okay, yes, the answer is correct. 4 minus 2 with a bracket, multiply 3 plus 4, and then shift enter. 14. Good, I got a few of you already done. I believe some of you also done, but just you haven't typed here. It's cool. Okay, this is a 1.2. For 1.3, how to compute the 3 with the power of 7 multiplied 8. Okay, it is also quite straightforward. So I haven't shown you how to put in the power, but it's a similar with a lot of software. Cool, for Syed, I already get your answer. Yes, exactly. So for the power, you just use a shift 6 with the arrow pointing up. And then for the power of 7 times 8, I just key in 7 times 8 inside the bracket. Then I'll get my answer. Okay. Okay, 1.4, the last one. A bit challenging. If you still remember this symbol, percent, how to use it to represent the output from 1.3 and the output from 1.1. Divide the output from 1.3, which is this one, to your output 1.1. Your number will be different from mine. It's okay. You just put in your numbers. For my one, it will be different. Okay. So how do we do for this? Let's say together we see this 1.4. Divide the output from the exercise 1.3. So exercise 1.3, my output is 25. So I will put percentage 25. Percentage 25. So you automatically say a percentage 25 have this value. Okay, this is what I want, correct? Divided by percentage, my 1.1 is 23. So your one could be any other values. Okay, this is my output. Okay. Cool, side. Very good. You just use a percentage divided by the input 22. Okay, we don't use the input value, we use the output value. So You use the output, so you can refer to the percentage. Percentage with the number will always refer to the output. Because the input is haven't calculated yet. We want to use the output value. Okay, so instead of percentage 25, I see some of you straight away you use percentage. Okay, it's not wrong because the last output is from the 1.3 is exactly the percentage. But there will be a problem also because if I run a few other times and I come back to this equation, I run again, it will be out because it's always referred to the last output. So it is not locked. It's not locked to certain numbers. So for a safe purpose, it's better you refer to specific numbers. Let's say I always want to refer to my 1.3 output, which is 25 for my case. So I will put 25 here so that your answer is not messed up after you accidentally run a few times. Okay. Of course, if you have a program that it always automatically run from the first step to second step, third step, it always follow the sequence without changing in between, then that's fine. No problem. You can, that's the purpose of using the percentage. It's always refer to the previous one. So that's perfectly okay. No problem on that. But I just want to let you know, if you are doing something like what I did right now, you may have to go back and run here and run there. Then the number referred to will be messed up, right? Okay, cool. I see most of you have done with the correct answer. Cool. So we'll go with the next one. Yeah, simple arithmetic. We've done it. So for the slide number 8, natural language input. Okay, this is something different from other computations software. Okay, something in the Wolfram language only. This is called before the AI in the ChatGPT came out. In fact, Wolfram's Mathematica already have something like this called AI in Wolfram's for the free language input that you don't need to key in the programming coding. You just type in as what we speak in English. Okay, but there are difference between the Wolfram AI and the ChatGPT AI or Gen AI is different because I'm not to go into that, but this one is more for technical. The Wolfram language here is knowledge base, which is they only can give you the output or summarize or computation or visualization based on the actual accurate data they have. They are not allowed to create something out of nowhere. Okay? They cannot learn something and then create something, which is what generative AI good at. But in the ChatGPT, in the Wolfram AI here, they are only focused on the technical knowledge base. Okay, they cannot create something else. But this is something good for the technical computation or technical use. For instance, this one, to call out something like this, if you see a symbol like this, it means that we are activate the Wolfram natural language input, not the standard coding input. Whenever you see the orange color, is the free form input. We call free form or free natural language input. So if I see this one, I can just type solve this 7x minus 2 for me. And then I shift enter. And this one, of course, it need the internet connections. Okay, if you have not connected to internet, this one you won't run because it send the input to the server in the Wolfram AI and then come back. It's the same with the ChatGPT like that. You need the internet connections. Okay, so you can see that without I knowing the coding, it actually solved for me. The output is 2/7. Okay, even I want to do something. Okay, plot something like this. Plot this curve and this curve, and the x is from 1 to 8. I say something like that, and then shift enter. It will be doing this curve for me right away. Of course, it will be a simplified one. It won't have all those title, all those other assist, all the wording region. This one we can add later on, but it helps us, especially a new user, quickly get the answer we want, quickly get the output we want. And also, this is the free-form input, what I speak English. And it also show me if you want to get this result, this is the actual coding we can type in. So from that, we also can learn how to get the coding right if you want to learn the Wolfram language to get the similar output. So this is very powerful. Okay. Let us try this one. Find the integrations of x squared with the sign with the power of 3x dx. Okay. For this one, how do we key in this? So inside here, I want to call out the freeform input or a natural language input. I just type, if you still remember at the top here, I type equal, okay, or 2 times equal at the beginning of the input. What is the difference between the equal and 2 times equal is, with a single equal, you get a simplified output. Straight away go to the answer. Give me the answer. If you type double equal, you give me all the relevant answer. Not only the simplified answer, but all the relevant, including the visualizations, data, or statistic, all came out together. Let us try on this one, right? So let's say I want to find the integration of this one. To call out this freeform input, I type equal sign. You'll see it becomes something like that. And then instead of using the coding, I say do the integrations of, maybe I don't want to type all everything like this as a copy and paste. Okay, enter. Right. So you can see it do the integration for me, get output right away. How about compute the area between this y and also with the absolute number of x and also x squared minus 6. So I can also do this. Type the equal sign at the beginning of the input and then key in whatever as what I speak in English. So I just put this one. You calculate or compute the area for me automatically. Well, you see the bracket, it turned into black color. It means it's communicating with the server. So we might need to wait a while for the result to send up and download. Okay. It will be slower because I'm using Zoom to present and you are using the Zoom to see it. So it also take up some memory, also the bandwidth. So it might be a bit slow. Okay. Still running. Oh, okay, it take a bit longer. I think I made a mistake. I should be pre-run all these things with a result so that you don't need to wait on this one because it takes a while for all the computations. And beside this one, I also want to show you why when we are using the double equal sign compared to a single equal sign. I think it takes much longer than it's supposed to have. So let me stop this one by typing alternate full stop. You stop the computations. Okay, let me check back this one. It's a bit lagging. The kernel is not responding. Let me abort it. I think because the previous kernel is running. Okay, let me see this one. Okay, compute the area between. Let me run it again. Still running. Any of you get the output? Maybe yours already get. Just my any of you, if you have the output, let us know. Okay, I think okay, now I get it. So you say, okay, you calculate the area between curve. Oh, okay. Oh, quite of you, many of you already get the output. All right, just me alone. All right. So, okay, click on this one. Yeah, get the output 27. Okay. As I told you, with a single equal, it actually go a simplified output. But if you use a double equal, you see more. If I key the single equal, but then later on I want to see the all the relevant information, instead of I using the double equal at the beginning, I can click on the plus sign here. You see there is a plus orange color sign. It means show all result. If I click on this one, oh, I think have a problem with my updating. Then probably I try the other one. A lot of things. Let me try this one again. Because this one I cancel the computations, it become haywire. Let me use a new input. Let's say this is a new input line, hit double double, and then x minus 2 over 7. You'll see the full output, including the visualizations. Oh, I think I need to restart my file. Yes, already. After I stop the computation, there's some error with that. Let me close this one and restart again. Okay. For those already done this one, you can see the example of after this at the below of the exercises now. There are some other questions you can see that we can get out from this free-form input. For instance, not only the mathematics calculations, there's a lot that you can get. Okay, for instance, if you are doing the chemistry, you can always ask, let's say I start with the double equal sign, because I not only want it to have a balanced equation, I want it to show me more details about these chemistry equations. Then I can just put in the chemistry equations, whether it's already balanced or not. I just type it and then run it with a double equal sign. It should be able to get all the informations. For instance, it now got the input interpolations. It say this is 0.2 mole of methane plus oxygen, and then the output is water and carbon dioxide. And the balance equation is here. Okay, it showed me the balance equations, and also it showed me the scometric, all the relevant informations, including the structures, and so on. All the relevant things is included. The substance properties, chemical name and formulas. And if you notice that at the right-hand side of your output, they also got a button called step by step. This is something happen, it will show up whenever there's a computations, including chemistry. And of course, it's applied to all the mathematics. When there is a step by step available, you click on it, it show you all the intermediate steps from the beginning until get your output. Right? This one is for the balance equation. It shows me the first step to balance the chemical equally equation algebraically. This is how it works. Add one to the right-hand side and then balance all this, you get the output. So this is something like that. Even including showing some other feature. I want to see skeletal structure, or I want to see fluid structures. I can click on it. You change interchangeably for me for the structure. You can see it's all changing, and then there'll be more like how to get an equivalent constant. This is for the chemistry. Okay, maybe you are not using the chemistry, then we can skip on this one. But you can see there are other things. For example, formula. If I want to find a water flow, maybe for a fluid mechanic, you can put this thing. Oh, give me the formula right away. I don't want to see all the relevant thing. Just give me the formula. Okay. Then show me the formula for the flow discharge rate, diameter. This is a formula. The flow discharge with the 2,500 pi times the velocity. If I want to see the full result, I click on it. It will explain all the detail within these formulas, including it create a calculator for me. whether I want to calculate for the float rate, then I key in the float velocity. In any unit that I'm familiar with, they will auto-compute. And if I want to find the float velocity of the fluid, I just click, I want to calculate, select accordingly, you change the calculator input. And then you can just change your input value, click compute, you do the calculations. And also give us all the formulas, result in different units, and also the relevant equations, which can be used directly. Okay? And beside all the calculations, formulas, we can use this one to call out the real-time data. For instance, I want to find the tides at Pulau Pinang right now. Okay, I just click on this one. Wolfram server, you actually can access to the data through the World Bank or through some organizations for all the data that host all this kind of data. You show us the data and call back for us. It's very handy and important if you are using, you need to access those data for computation or for modeling. This is all available. I think my connection is a bit slow. You time out for the connections. You try to use it maybe 15 seconds or 20 seconds. If you're still not receiving the result, you will actually stop it and time out it. So I feel like I didn't get the result. It's just because all the time out. It exceed the supposing limited, the time limitations. How we know this data came from or where it came from? Because for all the output we get, at the very bottom right, they will show a button the resource came from. So if you are using the data or certain information that you extract from here, you can actually click on the button at the bottom right to find out the where it came from so that you can use it for your report or your project with a proper citations. Okay, it's not something that you can simply grab from the internet. No, the data they get it is actually from a trustable source like the World Bank for certain country, GDP or populations or weather data. They all sources out. Like this one is for the weather data, the tide data. You even show us which stations you get this data from and when you get from. You show all this detail as well. I believe I'm not able to show all this one. It's taking too long. Even you can try out later on. Let me remove some of the result so that you release some of the memory in my notebook. Okay. You can try out later on with all this numerical, with all this natural language input, so that you can find out. For instance, I want to show you if you are need the data for certain biochemistry or certain disease, it will show us all the relevant informations, including the statistic about this disease, what is the range of the patients, of male or females, the age, and what is the cause of the disease, probability of the cause of disease. It's all here, including, I see the medical codes for this disease, and some of the risk of this disease, genetic condition, head injury, depressions, hypertension, typical treatment, the statistic for US patients with diagnosis in a given year, like male, how much, female, how many of it, their average age, and also their reported symptoms, their other conditions. All those data is handy available. Okay, and it compute it in a statistic visualization performance for the end user. Straight away you can grab this one to use it directly, and you can say, okay, where this data came from. As I mentioned, if you go to the page from where the data came from, I'll show you later on at the end of this slide. You can go there and then you can find the sources of this. I'm not going to try all this one. I urge you to try on later on. Like you can find out the earthquake data for the past 10 years, 20 years, 30 years. Maybe you want to do some computation for areas for certain mountain or certain building height compared to what it would do all the comparison. Okay, this is the page wolframalpha.com. Okay, you can click this one to see what is available with this knowledge-based engine, what kind of thing you can call up, what kind of data you can get. So in this page, you can see there will be area for mathematics, science, technologies, society, culture, everyday life, all those are available. Okay. For instance, let's say I want to see the earth science. This one, I think I have an example. Okay, you can see what kind of thing you can ask inside Wolfram Mathematica. Of course, in this page, you can ask as well in this browser page, but this browser page, they actually have a free version and a pro version. Okay, for the free versions, they have a limitations. You cannot get too many data downloaded. But if you have the Wolfram Mathematica license, the interface you see just now here, you can access to the server in the Wolfram Alpha. You get exactly the same thing in the website, but it's free for the user in Mathematica. You don't need to pay anything. But if you come to this website and you type something like that, let's say I want to find the, let me click something. Give me the, maybe compute the property of the ocean at a given depth. When the ocean at 300 meters, I click on this one. Okay, this is the input, ocean at 300 meters. You say it came out with a computation input with a different temperature, with the salinity, and then you can compute, say, okay, this is the output, this is the input, this is the result. Okay, all those, you cannot download all the information because this is free version. But if you do it in the Mathematica just now, all information is for us to download. And then you might wonder, okay, just now as I say, where to get the information. I can come here to type at Penang. Okay. Straight away it comes, it's much faster compared to what I do in the Mathematica, because Mathematica I running so many things. You say, okay, types. You know Penang is referred to Georgetown, Pulau Penang. Straight away, know this one and give me the result. Okay, in the high tide for the today, October 9th, Wednesday, 3 a.m., 3:23 a.m., high tide, low tide, 10:12 a.m., and some other thing, information about that tide. Average, okay, and the tide measurement station, show me which station is Penang and the coordinate where it take. Okay. If you want to find out all the information, you can see there's a satellite. It won't show the source because he already gave me the station. Maybe I ask some other thing. You show me the source. It will be a button here for me to click where the information source came from. For instance, maybe I say Malaysia GDP, or compare. You can say Malaysia GDP compare with Singapore or compare to Indonesia. Okay. Straight away, you get an input interpretation. You know, I refer to Malaysia, Indonesia GDP nominal, and this is a result. Is have a date of 2022 estimate. Okay, or here is a source. You can see this is a source. If you click on this one, it told me where this information came from. Primary source is from a Wolfram Alpha knowledge base 2020. External source, this is from World Bank, World of Development. You can further click on the external source link. Okay, this is how we can check back where the information came from. It's not grab anywhere from the website. No such thing. It's a knowledge base. It is a knowledge base. You must make sure the data of source is accurate. So this is where we can further go to this page to find out more. All right. I hope I didn't confuse, but sorry that I'm not able to show all this output, but you can try on later on. All right. think we is already over 3. Let me go through a little bit before we take a break, so that we can finish as much as possible for today's material. So just now, I will show you with the natural language input, okay, without using the coding, without using the Wolfram language. But we also need to learn Wolfram language in order to create let's say you want to write an algorithm, a much more complicated one, you must also use the Wolfram language as well, rather than everything depend on the natural language input, because that one probably give you a small query, small coding. But if you come to a more complicated one, we still need to come back to write a proper language so that we can make sure all the program running smoothly. But it's not difficult compared to a lot of other tools. Wolfram language is much more easy and much more consistent compared to other tools. There's only 4 rules in your Wolfram language, the coding. Okay? All the functions, I say 6,000 over functions that built in Wolfram Mathematica, they all must begin with a capital letter. So whether it's a function called plot, or solve, or expand, list plot, you can see they are always start with capital letter. Okay? And the good thing about the function name is, from the name itself, we can roughly guess, or we can roughly know what this function is about. Okay, this is the first rule. Start with capital letter. Second one, all the functions will follow with the square bracket. Okay, open square bracket, close bracket. After the plot, you put something like that, so that you put your expressions inside this bracket. So what you want to do with the plot, you put inside there. Okay, so this is a square bracket. Third one is called curly bracket. Okay, a big curve. Curly bracket is for a number of elements. You have certain element, maybe you got an element A, B, C, D, E. You got element from 1, 2, 3, 4, 5, or a list of number, or maybe a range. A range is mean you got a minimum from 0 to maximum 100. Then you use the curly bracket. So this curly bracket is for a list of element or a range of things, okay, by using curly bracket. And lastly, we already tried. You write everything you've done, you want to execute it to run a computation, you press Shift plus Enter. Okay, this is only the 4 rules. Capital letter, square bracket, curly bracket, and Shift plus Enter. Okay, let's try it. First one, computation example. Of course, we already do the computation 250 over 3. It's very easy. But then we can add something called N. N is a simplified for the numerical output. Means that I want to convert this value to the numerical value. So it's called N, capital N, followed by the square bracket, and put everything inside here. So this is how it works. The first one, if you Shift Enter, you get your output, 83.333. Okay. Second one, also expand. Or I want to expand these computations. Okay, a plus 5 multiplied by a plus 9. So if I put a expand capital E with the square bracket and run it, I get my output. Okay, similarly, solve. I solve capital S, and then follow by my equations. 2x minus 7 equal to 0. But one thing bear in mind, as I mentioned in the notes here, we use equal, 2 times equal for formula in Wolfram Mathematica. Okay? Because single equal, 1 equal is using for assigning a value for functions. So the a equal to 5 means I assign the value of 5 to the a. So you use single equal. But for formulas, for equations, we always use equal to differentiate between these two. So I want to solve these equations, right? I put comma. Why? Because after comma is I want to solve it in terms of x. Okay. So I run this one. I get my value. X is 7 over 2. This is solving. This is also the same thing, but you can see this function solve, it have an n at the front. So what n stand for? In Mathematica, it stands for numerical output. So it solve it, straight away convert to the numerical output. So the answer is 3.5. So it's solve and solve. Okay. And also we get something called simplify. And then I can have all this expression inside here. I put all together and simplify this one. You straight away do it from x to a power of 4. Okay. Now I need you to do some exercise as well so that you can put everything together. First one is very simple. Use the function called integrate. Okay. And then f here is for the expression or your formulas x to find out the integration of x2, x power of 2. So this is, we want to integrate x power 2 with the x range from the minimum to maximum. So using this template. So write the template inside here and run it, see whether you get your output. Okay, do it now. Once you've done it, you put your coding in the chat room. Right? So see who can get it. And show me the answer as well. Okay, just use this template, follow exactly the same thing, just fill in. Okay, I get one from Tom. Integrate x2. That's great. Good. So as right by Tom. So we just fill in accordingly, integrate. I get the answer from side 250 over 3. That's right. That's right. So the function is x to the power of 2. And then I give the range. Square bracket is for a range. So x is from -5, comma, to maximum 5. And run it. I get my output. Congratulations. Okay, let's try the second one. You want to use the function solve, okay, to find a solution of 2 equations. It's not one equation, it's 2 equations. How do we put 2 equations inside this function to solve it? Okay, and what is the variable that we want to solve? Right? Okay, you can try how to use a solve. Okay, you follow the format. And what is the equations we want to put in? We got 2 equations. So how should we put multiple elements? One equation is considered one element. But now I got 2 elements, 2 equations. Okay, I see somebody using the plus n sign with it's a standard programming. Cool. That's right. That's right. Anyone else? Remember, there's a hint. Use curly bracket for multiple arguments and elements. So the hint here is using curly bracket or for the range. Separate with comma. So yes, Tom, I saw your answer. That's great. We can use this curly bracket exactly like Tom show here. Is 2x minus 7 equal to 0. The first element of first power formula. Separate by comma. 3x minus 2y equal 0. So this is a second formula. I want to solve this one. Solve for what? I got 2 variables to solve. X and Y. Because it's 2, so I use another curly bracket. I solve it in terms of X and Y. So this is how we should write. So get your output. Okay, anyone else get it? Sai also get it right. You use the other method, but it's no problem. You get the answer exactly correct. All right. So this is a simplified for this input using curly bracket. Now we come to the list. I will emphasize on list because for those of you dealing with the data or elements, you need to use a list a lot with a lot of operations. So I'll show you some of the basic way to deal with the list. So list, like I showed you just earlier, curly bracket is to include a list of elements. So the element, it can be anything. It could be numbers, it could be alphabet, could be text, could be picture, could be any symbol. Even it could be just a video file. It could be a audio file. It could be a formula or anything. Okay, so this is how we put it together. And if it's all the number, you can use a function called list plot. All this thing, plot it. So if I run this one, the first one let me run this one. So this is the output. The second one, I run it again for this plot. So you show me, you plot all these things, right? According with the sequence 1, 1, 2, 3, 5, 7. Plot it. This is called list plot. Okay. Then we got something called range. Okay? Range is also very commonly used. It's a function that makes a list of numbers. So if I use a range template like this, it means that I create a range of numbers start from 3 to the maximum of 20 with a step size of 5. Okay, if I run this one, you'll see that will be from 3 plus 5 equal to 8 plus 5, 13 plus 5, 18. You won't have a 23 because 20 is the max. So this is how we create the range. Okay, but there will be also a shortcut. If you are starting the range from the 1, then you don't need to type the initial value. You just put range 20. You automatically know that you want to create a range from the minimum 1 to the maximum of 20. If we didn't fill in the step size, by default is 1. Okay, there's a range 20 will be 1 to 20. And I can further add a function on top on another functions. So I can have multiple functions put together. So you apply the range first, and then you go to outside, apply with the reverse. So as you can imagine, the output will be 20 all the way back to number 1. Okay, this is a reverse for the range. And we have this thing to deal with the range reverse. Also, we can join it if we got a multiple elements, like multiple lists. We can break all the multiple lists, become one single list by using join. Okay, if I use join, it put all the elements in different lists, become one single list for further iterations or further calculations. Okay, I'll show you some other operation on using or apply to the list. For those of you that dealing with data, this is very handy. So if you have a list of elements, then if you add or multiply or add any value to this list, it automatically apply to the individual elements. Okay, 10 will be added to the first element, second element, third element. And if multiply with the another list, you actually multiply accordingly. Okay, first multiply to the first one, second multiply the second one, third multiply to the third one. Okay, you match accordingly, just like using a matrix. Okay, and we can also apply something called like sorted. This is quite straightforward, so I will just quickly run through it. You also can just shift enter on every input to find out. Sort, small to large. Length, you show me how many elements inside there. We call it length. So what is the total numbers? This is also very important. If you've got a huge group of data, you don't know how many of it, you just apply length, you automatically calculate how many number of it. Total, You just sum it up. Okay. Count a list of elements, and then how many of them are specific A. How many of them are A? So if I use count, it show me inside this elements or list, there are 2A. Okay, this is called count. One important function is called part. Part is extract out specific numbers from the list. So part from this list, which number? The third one. So it will be B. Okay, part is specific, call out the number in sequence. You take the first few numbers. If I put 3, you take the first 3 numbers. Okay, or you put 2, you take the first 2 numbers. Drop, similar with the take, it's just opposite. It drop the first few numbers. 4, it means it drop the first 4 numbers. Okay, we can actually combine the take or drop all together to specify the output we want. For instance, this one I drop, I want to drop the not only a 3 at the 3 number at the front, I also want to drop number 5. I want to drop a specific number, the 3, number 8. No, I want to drop the number from 3 to 8. 3 is here. 4, 5, 6, 7, 8. I want to drop the number from 3 to 8 in a step size of 2. Okay, so it will be 3, 5, 7. So you drop these 3 numbers. 3, 5, 7. 8. 8 it won't drop because you need a step size of 2. 8 is the same thing. I can start from number 1. Take the number 1 until -2. It means the second last 2. The second last second 2. So it's a G. So I want to take from 1 to G in a step size of 2. So it will be A, C, E, G. Okay. So you take from number 1 to the second last, which is G, with a step size of 2. So this is the 4 numbers that I take. Okay. You don't have to remember all these things because we just need to know there's a functions that can apply to the list. And then we can always refer back to the documentation to find out more. Because there's no way we will remember all this 6,000 over, and the number of functions is going to getting more and more. Compared to a few years ago, is only 3,000 over. Now it's already more than, I think it's nearly 7,000 now. Okay, but it's okay. We just need to know there's a function there. Then we can go to documentation to find out. And something that called integer digits. It means that it convert the number inside become a single digit. Okay, that become it separate become an element of 4 digit 2024. Okay. I don't know why you want to do this, but some certain computation or certain way you may need to do this because you're going to find out a list of number of how many elements that you need to extract out. Okay. There are also other relevant functions in documentation like take, drop, delay, insert, prepend, append, join, and so on and so forth. That for those people who want to deal with the list of number, you can check out on this on the documentations. Now let us do some quick exercise as well. 4 of them, 3.1 to 3.4. Using the functions that I showed you just now, you should be able to get the answer. Okay, the first one is very easy. Just try it out. I'll give you a couple of minutes. Then you share your answer, then we move on. Right? Make a list of the first 10 square. So there'll be a square for a number from the 1 to 10. But they need to be in reverse order. So how to make a list? 1 to 10, but they need to be squared. So we actually take one step at a time. First, we forget about the reverse first. We just try to make the first 10 number in square. So that will be involving range. Yes, we're using range from minimum 1 to 10. You want to square it and then only make the whole thing in reverse. Anyone? Okay, I see. Okay, reverse range 1 to 10. Okay, you're almost there. So let me see if we use a range 1 to 10, what it looks like. So the output is like that. Okay. Of course, if we put a reverse, it will be like this. But how about the square? How do we apply the square to our output? Yes, just adding the square to the range. That's exactly how it works. So you put a square for the range before it reverse, then this is how you get it. It looks like difficult, but actually it's not, right? When I show you the answer, you say, oh, okay, I should know about this. Yes, it's quite straightforward also. It's just that sometimes it's something new to us. We need some time to think about it. So this is how you get this one, reverse first 10 square. Okay, let us try the 3.2. Try to plot the value from 24 to 4. So from many to less with an increment of -4. So 24, 20, 16, 12, 8, 4. And then you get the value and then you want to apply the hinge using the list plot. First, you want to create a value and then you apply a list plot to get the output in visual. Anyone? Anyone? I know some of you already done. Just share with us. We have like 60 over people here. There must be somebody already done. That's for sure. So how to get the range? You already know we can create a range of number using starting point, start to end with the increment. You create a range of number already. And then you just apply a list plot to the whole thing. Then you get your output. Anyone? Maybe I want to call it Mastura. Okay, I get from Uma. A range. Okay, you get a range. That's correct. That's true. One more step. Apply a list plot to the whole range. Then you get your answer. Oh, I get it from side. Cool. Let's read. Let's write. So we apply the range. So one step at a time. So let's say we create this one first with a -4. So we get this one. And then we just apply this plot to the front, closing with the square bracket. you get output. Just like that. Okay, this is how we plot the value from a range of number. Now, the third one, use a take and drop to get a sequence 11 to 20 from the range 100. So range 100 is what? It means that we have a number from 1 to 100. So how to use a take and drop? And I only want to get the output become 11 to 20. So this is what I want. The rest I don't want. So how should we get this output that apply to the range 100 using take and drop? If you still remember, take means I take from the front how many numbers, and drop, I drop from the front how many numbers. Any try? Okay. Yeah, just give you a hint. We drop because I need this only. Then what I need to do is if I drop the first 10, then I left only this. With this, I just take the first 10 and ignore all the 90, and I get my answer. So what should I do is I drop it first. I drop the first 10. Okay. Now 1 to 10 is gone. And then I apply another layer on top of these functions. So now it's 3 layers compared to what we did previous is only 2 layers the most. Now you can do 3 layers. You can build your algorithms or functions layer by layer on this thing. It's how actually we build out our algorithms from pages to pages, all the same thing. It is how we get by using these 3 functions: range, drop, and take. You get your output. And lastly, using part, if you still remember, is to extract out certain specific elements. Okay, using part, sort, and integer digits mean convert your output become individual numbers. To find the second smallest digit in 2 with the power of 200. 2 with the power of 20, sorry, not 200. So I got these numbers. Okay. And then I want to find the second smaller digit, means that I need to break the whole thing become a digit. And then I want to find out the second smallest one. So we think one step at a time to solve this. Anyone? Any taker? Uma? Can you get it now? Outside. How about Tom? Yes, I think I don't get the answer. Let me copy his functions and paste inside here. See, the answer is 1 exactly. Congratulations, Tom. You did it right. So I want to find out how you do it. You can separate one step at a time. So first one, you get the digit for this 2 to the power of 20. You break into digit, and then you add a sort to the front. You sort it, and you want to find the second smallest digit. Second smallest is this one. That means that you want to extract the second number from this list of elements. So I use part. The whole thing, I want to part the second element. So I put 2. That's how it works. So we get 1. Thank you, Tom. Okay, I hope you get this one. All right. Now we come to the slide number 13. These visualizations. After that, I think we can take a break, 5 minutes break, until we finish the table. Probably I need to go a bit faster in order to finish the whole thing. Right. So for list visualizations, we already know about this list plot. You mean just plot the point to our output. If you want to the line to connect, you can use something called list line plot. Okay, you connect this line plot. It's exactly the second output, the second line here called list line plot. Previously, we doing everything and then we get the output. But now I want this output to, I want to give a name to this output so that I can always call this output, or I can always use this output whenever I want, because after I give it a name, that'll be easy for me to call it out. So I give a name called G1. Give a G1 with an equal sign means I assign a value or a name to this line plot. So it's called G1. Okay, G1 is now like that. Before I run this one, if you pay attention, like this G2, before I run it, G2 is in blue color. But if after I execute it, it will become black color. What is the meaning of the color? It means that when it's blue color, is something unknown variable. It's a something unknown value inside this G2. But after I assign it with the equal sign, after I execute it, now the G1 become something that contain a value inside or contain something inside, contain a definition inside. So that's a difference between the color. G1 is this. Now G2 is what? G2 is a bar chart. If I run it, you pay attention, the G2 become black color. So G2 is a bar chart. G1 is a this line plot. And if I got a G3, another pie chart, it's like this. So this is a G3. Maybe I can make this one smaller, so it can fit in one screen. Okay. Now I have this line plot. I got a bar chart. I got a pie chart. Okay. All is given different name, G1 to G3. And then with that, I can actually using something called row or grid to put all the visual output together rather than one single output. I can put them all under a single cell. Okay, this is how we use a row. Okay, using this function called row, if you apply to row with different element, the element here I got a element, first element called AAA, second element called B, third element called CCCC. If I put row together, you actually put them together, all the elements put side by side. Okay, they connect together. If I put a comma after this element with specific that dash dash, it will be inserting that dash dash in between these elements. So it will be AA dash dash B dash dash CCCC. This is how the row functions used for, okay, to arrange multiple expressions inside a row. This is for one single row, but sometimes we want to have multiple rows, so we call a grid. That's another function to display elements in a two-dimensional grid. Especially if I got elements ABC, another element XYZ, but they are under a bigger list. So this larger list, I put a grid, it will become 2 row or 2 layer. ABC at the top, XYZ at the bottom. Okay, this is how it works. So if I put a grid, I said the first one is G1, G2, and G3. Okay, this is the grid. And then I can add in, say, of course, this is something I want to put further. If I don't put this one, it also can. I remove this one, will be simplified output. So all those things that add a frame with the item size or scale, I don't make sure the output is what I want. I can further add in some we call options. This is something you can find in the documentation under the grid. Okay, if you go to the grid, if you put your mouse on the grid here and click on the this information mark and click on it, you bring us the documentations with the grid, and inside here you can actually find out what is the detail and option available for this function grid. Okay, for grid you can further add in the alignment, you can add in the background, add in divider, frame style, the spacing, all those can be added. And how to add, you can further scroll down to check out the example. It shows us the example, how to use this one, maybe how to change the background. If I click on this one, you can see, okay, this grid, I got a table. The background is pink color. This is how I use background. I even can specify background from the first row or first column is pink, second column is gray, row is none. You can either specify all those things. Sorry. All right. So this is for the row. If you want to find out the option available, you can always put your mouse on any functions and click on the information. It brings us straight over to the documentations, and then you can check on that one. So this is how we can use the row or grid to put our output together. So let us try a quick one. Put the exercise, put the above graph using a list plot, bar chart, or pie chart in a row with spaces 50. Okay. Yes, we can have a break after this one exercise. I think I just do a quick one. We do it together so that we can save the time on this one. So we're using a row instead of using grid, row, and then okay, we have a list plot, bar chart, and pie chart. We got a G1, G2, and G3. Straight away using a G1, G2, and G3. So we got a three element. We're using the curly bracket, G1, G2, G3. Okay, and then I need a spacer. Spacer is straightforward. It means how many space in the pixels that we want to put in between these three elements. So you can easily call out something like that. All right. Okay, I think now it's 3:48. We just take a 5 minutes break. We'll come back at 3:55. 3:55. Then we'll continue on this table. And you can dismiss right now for until 3:55. And for those, if you have any questions, you can still stay on. I will be here to glad to answer any question that you have. All right. Thank you and see you in 5 minutes. Bye. All right. So I'm back. Okay. You see any questions so far? I think everyone is okay. Okay, we still got about 10 slides to go, which is quite some important slide as well. Okay, I got a question. I'm not clear with sections 8. Sections 8. Let me see which one is sections 8. Umar, you want to be more specific? Which sections 8 will you refer to? Slide 8, you mean? You mean slide number 8, this one? Okay. Okay, for this natural language input, is extra features that allow the beginner or user to call the data or to complete the functions without knowing all the syntax or the coding formulas. You just input as what we speak in English. Then the Wolfram Mathematica would know how to do it for us. For example, let's say just now I got a calculations of okay. For example, let's say I'm using this one. Maybe I copy the whole wording here and I put it inside anything here, a new input line. I can use the free-form input or Wolfram alpha query. Let's say I try with the Wolfram alpha query, which is a double equal sign, like equal, and then I just paste in English and then run it. You send the whole sentence to the Wolfram alpha server and then try to understand and came back with the output that we want. I think I should copy and paste as a text. I didn't copy and paste as a text. Let me delete all this thing. Because I copy the time is not a text, it's a something like picture. Copy as plain text. Let me try again. Okay, it should work better right now. And then after keying here, I enter. So I want you to do the integration of x squared, where the x is from -5 to 5. So you actually, you don't need to use the functions in Mathematica, but you try to understand what we want. So you say, this is what we're looking for, and this is the relevant visualizations, and that is how they you want. Even it can include a visualization interactive for us. Say number of sub-interval. We can choose it to see the error will become smaller and smaller when we have a smaller sub-interval. Okay. So it call out all the relevant visualization for us as well, including indefinite integral. It also came out. Okay. You can see the step-by-step solution. If I want, I can click on this one, step-by-step solutions. Then you show me how to get this output. Okay, compute the definite integral, first step, second step, and third step, and then apply the value, and this is answer. So that is how the we call knowledge-based engine of Wolfram AI. So it's not only for mathematics or computation, it can be anything. All the data available, like area of, let me try this one just now because of the computations time up. So it might not be able to run, but let's see if it's running right now. Okay, now it's smoother. So it's an area of Pacific Ocean divided by Atlantic Ocean. It got the data so we can get the result right away. You can show the detail if I want and click on this one, see anything in detail. We say, okay, this is the area for Pacific and Atlantic. How about like earthquake near Indonesia? Maybe I just double equal sign. It is one here. You call all the data or the past history or the earthquake recorded in Indonesia. Okay, so this is a result. Last 2 months, you can choose what's the last 2 weeks or magnitude larger than 4 or what. All those things options available. It shows us from August 12 to October 7 with the different scale and where it happened. So this is the informations that you can call out with the magnitude. All the details given as well. Okay, and if you want to find out where's the sources, you can click on this one. It links us to the Wolfram Alpha page, and then from there you can check out the resources of where the information came from. Okay, so it's not something that it came out from nowhere, but it actually is deferred to somewhere else. And all the data, all the graphic, you can straight away copy and then make use of it. If you have the graphic that you want it, you can save the graphic or bring the graphic or save it, and maybe you want to use it in your PowerPoint or in your Excel, in your any other way. You can just copy the whole thing and paste there, right? Even including the data or visualization as well. So this is how it came out, like calculate something. And hopefully it's running smoother right now. From the coordinate in the Earth from one point to another point, calculate the great circle distance. So not only it calculate out, you know from where to where, which is 13,191 km, but it also break into different units. And I supposedly it should give me the visualization as well. Yeah, the whole thing, the map came out. You can have the whole thing like that. Here to there, and then fraction of Earth's circumferences, all the relevant informations from your query. Okay. So that's I show you, you can go to this website to find out what is the question you can ask that relevant to your works. Maybe you are involving with the social science data. Maybe you can find something like that. Or maybe you're involving more on the maybe and on a chemical thing, or maybe on the medical science or image thing. You can go there and find out more. There's a lot of information out there. Yeah. All right. Thanks for the questions. I agree you asked this, so I have a chance to demo what I left behind just now. So we come back to the tables. Okay, table is a function which is very important and commonly used because it's so powerful and it's repeating using on a lot of codings. If you check on other people's coding in Wolfram Mathematica, Wolfram language, you'll see table, it appears quite a lot. So what a table means that it actually make a list of an element repeated with a specific number of times. So whenever you need something for iterations, this table is something that is very powerful for that. Okay. For first one, the simple one, table with the expression, the formula, and how many times you know, n is how many times you want to run it. So for example, this one, I got a table. I want to list out 5 with 10 times. This is a list with the number 5 repeated 10 times. This is what it means. So this is how it came out. The first one is the output, and then how many times. So if I want to have this output instead of just a number, it can be anything. It can be a pie chart. Okay, this is the output. The output I want, the pie chart is in 3 portions, 1 to 1 to 1. So I want to repeat 3 times. So how it came out. This looks like a 3 pie chart. Okay. And also, instead of a fixed output, I can put something like unknown iterations, n. See, my output is n plus 1. Okay, how many times? The n is to be from 1 minimum to 10 maximum. So it will be 1, and then 2 add in, 3 add in. So your output will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is how it works for iterations. So with that feature, instead of doing a simple output, we can do a lot of changes and a lot of possibility. So for instance, I have a range. Range, it can be from, let's say you can see this one is n is to the 5, maximum 5. You don't have the minimum value because it's assumed minimum value is 1. Whenever I don't put the beginning value, it means it's start with 1 to a maximum of 5. So the range will be 5 elements. The first element is 1, second element is 1, 2, third list of elements is 1, 2, 3, 1, 2, 3, 4, 5, and until the last one, 1, 2, 3, 4, and 1, 2, 3, 4, 5. Okay. So for a table, I can also have multiple output with inside a list. So this is my output. My output, I want to have x, x plus 1, and x squared. And then the x is start from 1 to maximum 5. So if I run this one, I can get the output like 1, 2, 1. When x is 2, 2, 3, 4. When x is 3, 3, 4, 9. So on is how it looks like. So it's for table repeating the thing. So with that, I can create a list plot easily. Say my table, I want the output to be x minus x squared. The x start from 0 to maximum 1 with a step size of 0.02. So this is how it looks like. I can easily create something like that, okay, by using a table. Once you understand the template or how it appear in the wording, which one's for what, is quite straightforward because it's always the same. You always follow the same pattern. Okay, with the output you want, how many times you repeat, and then from minimum to maximum with the step size. So we do some exercise right now. One question only, make a table or list of digits for the 10 square. Okay, the expected output is something like that. Okay, your output will be 1, 4, 9, 1, 6. 1, 6 is one list, 2, 5 is one list, 3, 6 is one list. Okay, this is how it looks like. Think about it, how to give you a hint. We need to apply with the, I think it looks like 1, 4, this is like square of 2, square of 3, square of 4, but it's separate into 2 digit. Separate into 2 digit. That is what exactly the function we do just now. Integer digits, if you still remember. So it break them into integer digits and become group of lists, 10 of it. Try it, see you get this one. Okay. Okay. So it looks like you need to use a table to create an output repeatedly with a range from what to what. Yes, I got a answer from side. That's great. It's table x to the power of 2. Okay, this is the output you want. And then it want it to be the x to the maximum of 10. Okay, that's what I get. Okay. However, you need one more step in order to create something like that. So break into a list of digits. I want a digits. A hinge using the integer digits. Okay. I think you already know. We just add a integer digits. Digits. You may say, how can I remember all the functions? Yes, we also cannot remember, but we know there's something about this. So we can also always go back to documentation to type something about digits. Then you list out all the things about digits. Okay, or I'll show you later on how to find some things. Maybe you have a similar memory about some functions, but you cannot remember the whole name. Then you can use the find functions to get this one. Integer. Okay. This is how it looks like, right? So this is how we apply integer digits to the table output. Then you get the output, right? All right, good try from Uma and Sai. That's great. Okay, now we come to the next about the plot, simple plot and plot 3D. Okay, simple output. For instance, plot is always referred to 2D. We don't say plot 2D because its plot is already 2D. When it's not 3D, it's 3D, then we say plot 3D. So plot, I plot a sine x, the x with a minimum value, negative 2 pi to a maximum value 2 pi. Okay, you can see the sine. Remember, it has to be a capital letter because sine itself is a function that already built in. Okay, for all the function in Wolfram language, it must be start with capital letter. So pi also start with capital letter. Sine, cosine, tangent. So you must remember that if you put a small cap, you see sine will be in blue color. It means that you have no definition. You don't know what is sin. It's just any single variable that no value. So you put a capital S, now in black color, you know this is something. So we plot sine x with a range from negative 2 pi to 2 pi is what we get. And for 3D, it's straightforward, plot 3D. And your functions is to include x, y, and then you give the range, x range, negative 3 to 3, comma, and y range. And straight away, you can get a 3D plot. It is how we get a 3D plot. And if you put your mouse and left button, click on it, hold it, and you move around, you can rotate the whole thing. Okay. And if you want to zoom in and zoom out, you also can press the control button, press it, and then use your left mouse, click, and then move up and down. Okay, click your left mouse button and also with the control key together will be zoom in and out. If you press a shift with the left mouse button, then you can pan it, move around. Okay. If you didn't press anything, just the left mouse button, it will be rotating. And if you like this output visualization, you can always move to the angle that you want and then right click, save your graphic into any graphic format, PNG, GIF, or anything that is available, even like PDF, EPS, GIF, BMP, JPEG, is all available. Then you can use it in other tools in other software as well. Okay. So this is a 3D and 2D plotting. Okay. There are a lot of built-in options available for plot because right now we are using the default output for the plot. There will be no labels, no regions, no any other extra thing on this graphic output. Those things are all controlled under options. Options inside the plot or plot 3D. So what those are available, you can go to plot. Let's say I click, or maybe you can how to access this one as I told you earlier. If you got a plot, you put your cursor on the plot. Okay, you put your cursor on it, and then you appear the information. Okay, you can click on this one. It brings us straight away to the documentations, and then with the plot. So I want to find out what is the available options for my plot output. Okay, you can always click on the second one, detail and option. You click on this one. You show us all the available options, the built-in the user can define with. You further scroll down and say, okay, the following wrapper can be used for the function. You can add in the button, call out, annotations, or highlighted, hyperlink, label. Then how to use this, we can further scroll down and see the example, the call out. You can have a label on above, label on below, before, after. You can add all these things, or maybe you can move mouse over, you can came out the label at the starting of a curve or end of a curve. Those are all available options for your plot. Then your plot can have extra like axis, can color functions. Maybe you can add the fillings, can add the mesh, and can add the maybe a plot labels, plot highlighting, plot point, plot range, plot style. All those are the built-in options. So you can see even this like highlighted, you can add in. When you mouse over to the curve, you got a drop line to the horizontal and vertical, and got a you can have a ball or have a different style. When you mouse over, the line will be thicker. You highlight it, or it will be a X light, Y light. All those are options. You need to add in your function, only you appear. How to do this? You can further move down to the example and see all the things here. Okay, maybe I want straight away go to the options. Okay, go to the options here. I want to find out how to add in the filling. Okay, let's say filling is here. Okay, this is the filling. Let me go to this one. Okay, the filling. Okay, plot. I plot a sine x, cosine x. Okay, the x is from here and here. Filling. I just put a comma inside this plot functions. I put another comma, say filling, and then follow with the arrow pointing to the right. The arrow is using negative, larger than, then it become arrow. And then say the filling is to the axis. So it fill between here to the axis, fill between here to the axis. And all those things, the best thing about the documentation is they are dynamic. Okay, this is not something uh, fixed. You can always change this one. Let's say the value from negative to pi. I just change it and then shift enter, run it. Your output straight away change. Okay, filling the axis instead of axis. What kind of thing I can have? After I key in filling larger than, it automatically appear the available options. Okay, you see it can be to bottom, to the top, to axis, to another. Let's say I click to the bottom and then run it. You actually apply directly. And best thing is the whole thing, they are so flexible. I can select the whole cell, whole bracket, right click and copy it, and then go back to my file. Maybe this is the file that I'm working right now. I have something similar that I want to apply, and then I just paste here. Okay, I paste here, and then I execute, I run, I get my output. And from here, maybe I can change the input value or output value to the one that I want accordingly. So instead of bottom, maybe I want to do the top. I run it, then is how it looks. So this is how we actually find out all the available built-in function in the documentation and apply it. You can always go to the example there to find out. So the exercise here, make a plot of sine x function with plot labels. Okay, you need to find out how to add in the plot labels and add in the filling. The filling we already tried. Okay, add in the filling. Okay. So you can try this. Create a sine x, a simple one with a plot. And also you can add in the drop line. Okay, the output will be something like that. A simple sine x. Okay, whenever my mouse move over on a line, you create a drop line with the value. Okay, this is how it looks like, and you appear a plot label. The label for this curve, you appear here, sine x. So how should we write this one? So of course, first of all, we try it with plot sine x. Okay, this is a standard one. Of course, the range for the x, I can use anything. Maybe I put 0 to 2 pi. It is also quite standard. I believe most of you can get this one. Okay. 0, 2 pi. Okay. Great. I see Syed already done with the filling. Cool. Very fast. That's good. Filling. Filling, I just add in filling. Arrow pointing to the right, and then select what do you want? Or is it mentioned how the filling looks like? Let me see the example. I'll put filling to the bottom, okay? So I just filling to the bottom. Okay. This is what I want. How about add in a plot label? So how to add in a plot label? So if you want to find out more, you can click on plot label, or I just show you the plot label. This is I already know the plot label is something available under this plot functions. So I just put a comma, plot labels, and what is the plot label about? I want the plot label to automatic. Okay, none, it won't show anything. Expression, it will show this expression. This is the expression. So it will show this one on the curve. So you show this one. So if I choose expression or choose automatic, because this one is only a straightforward one, so it will be automatic, or expression will do as well. So if I run this one, so you see you put the sign x here. Exactly at the y equal to 0 part. Let me try 2.2 pi. Okay, now you can see it. 2.2 move out, so they'll be adding a plot label to this curve with a filling to the bottom. Okay, this is how it looks like. And if you want, we can add in a highlighting effect drop line. So how to add the drop line? If you cannot remember, we can go back to the plot there to find out. Okay, let's say we go to the plot. How to add the highlighted drop line. Let's see if there is an example. Think it's a bit slow not right now. My program is a bit slow down. Okay, I think I straight away do it. Highlighted is to highlight your expressions. My expression is sine x. So I straight away put highlighted this one. Okay, highlighted this one. So add this one, highlighted what? With a drop line. You can find this one in the documentations, but I want straight away to go for this one. See, after I highlighted the sine x, of course, if I got multiple things, let's say I got a cosine s and sine x, I got two things. So let's say I got two things. I got a cosine x, and then second one is sine x. Whole element is like this. Maybe I will make you confused. So it's okay. I don't want to go further. You can see I got two expressions. One is cosine x, which is a normal one. So if I go to cosine x, it won't have any drop line. But sine x, I add a function called highlighted. So if I go to sine x, it will highlight it with the drop line. But cosine x, no, it won't have. Okay. If you want, you can also apply a highlighted with drop line or any other things. Okay. Right. Next, suggestions bar. Okay, this is something built-in functions for every output, so that to help us to quickly go to the next. For example, if I got the input x squared minus 10, I run it, it give me, of course, it cannot run anything, it just rearrange this one. But then you see, this is called suggestion bar. Something at the bottom, it always came out with different suggestions options based on our output. So for this output, it suggests, maybe I want to plot it, maybe I want to find the derivative for the x, or maybe I want to do the x integral, or want to do other things, or click on more, there's a lot of other things. Let's say I want to do integral to the x based on this output. I just click on these options. It automatically apply this one. And then with this output, again, it asks me, okay, do I want to do next for what? Maybe I want to, okay, I want to simplify this one, click simplify. Okay. So automatically apply simplify to this one. Then after that, it asks me, maybe I want to do a plot. Okay, I'm happy with this one to do a plot. So I click on plot, it automatically came out with a plot for this one. So with the first step, I key in only with the x squared minus 10. The rest is I just press button, press the button, press button based on the suggestions. I get my output. If this is what I'm happy with, I don't want to see all the intermediate step. I can select the function called roll up input. It combines all the input from all the intermediate different input cell, become one single input cell. So if I click on this one, you can see right now it become one single cell. Input 91. Okay, it means the first step, x squared, then you put the integral and then simplify it. After simplify it, evaluate the whole thing, and then you run this one, and then the last one, you plot it. After you evaluate, you plot it with the range for the x, get out. So this is something very handy sometimes for beginner. But of course, it's also good to have this one, turn it on. You can always refer back to this one with some automation. Like you get the output, you want to change to the numerical output, straight away click the output, you change your output from symbolic to numerical. It's very easy. So this is called automation suggestions bar. Beside the suggestion bar, another thing, assistant palette, I think this is also very handy because it's not like a lot of Windows application or a lot of buttons for us to click. But assistant palette is exactly the things that a collection of control buttons for us to use it so that we can easily create what we want. So how to call out this palette? This palette, it can be a pre-built-in and also it can be you yourself create palettes. You yourself define new palettes and the palette can be shared to other people and use as well if you want to, but that will be more advanced level. For us, we just use the existing default built-in palettes. So the palette is on the menu at the top here. You click on this one. Okay. For writing, maybe you want to create a report or presentation. You do a lot of writing on the text and then want to change the font and the alignments and the colors. Everything you can on the writing assistant. Okay. If you click on the writing assistant, you came out something like this on your right hand side. And those are a button that you can click. For instance, if I got a new input line here, then I can select, instead of always a click here and to select the title, you can straight away using here, say this is a title cell. Click, now become a title cell. Okay, title cell. Okay, this is what you want. Okay, maybe next input line here, I want to make this one a text cell. So the text cell, then I can straight away key, this is for the text paragraph. Okay. And also for that, I can highlight with the bold, italic or underline, and then text color, and also so on and so off. All those things you can apply, and then you can property for the cell background frame. You can add a frame for this one. Maybe a title one, you want to add a frame like that, and with the color, and maybe with the background. Okay. You just use this assistant to adjust your writing. And it could be have different types of things. You can have superscript, underscript, and then all those format that you want to is all available. Just click on it and then fill in accordingly. And even with special symbol or all the different things is available. This is for the writing assistant. There are other palettes as well. Like first one is maybe you can try classroom assistant. That would be much more. Classroom assistant, they include everything, including the writing assistant. You see, writing assistant is part of inside this classroom assistant. Classroom assistant include everything, including a calculator. You can build your formula in from here, which is exactly what we want to do for this exercise. So this exercise, we do it together, 7.19. You want to use a built-in classroom assistant palette to create the following input. So you want to create something like this. How to create this one? Then we just open up this classroom assistant, look for the format that you want. So this is a basic one. You can see all the basic format. If you want, you can make this larger to maybe 150. So your button will be larger. Okay. And maybe I make even larger, 200, so you can see much more better. And I want to have this integrate. So I don't have this in the basic, maybe I create an advanced. C is inside advanced. Okay, this is inside advanced here that's available. So in this input line, I select where I want to input. This is where I want to input, and then I just click on this template. Okay, that's it. Just fill in accordingly. So the upper is 10. I can just type 10, or maybe I can click the number pad here. And lower is 1. Okay, expression is x squared. X square, maybe you want to have a superscript, so this is a superscript, x square, and then to the variable, I can just use a tab in my keyboard, or I can use the button here, tab. So this variable is x. So boom, I done my template, and then if shift enter, it actually computable. And this one, if you are using for your presentations, or maybe for a classroom, or if you are lecturers, you want to use it to create a assignment, to create a exam paper, you can use this one. And if you further want, if you remember at the beginning, you can convert the whole thing in a traditional form. So in much more traditional format, and then maybe I want to align it. Let me open back the classroom assistant. I want to create this one and align the whole thing in the middle, so that I can create, ask a student to check on this formulas and to apply on this, everything, anything you want to do. You can do it here, no problem. Even change the color, everything. So inverse metric as well. Click on this one. We can just find out the available functions at here. So for the inverse matrix, you can go to basic command. Right? For matrices, okay, this is matrix. Okay, this is the inverse. I select the inverse matrix. Okay, matrix this 2 by 2. Then I just key in accordingly with my number pad. 1, tab 4, tab 2, tab 3 to get all this done. If you want to add a row or column, you just click add row, add column, then you can just do it accordingly. Okay. So this is very handy with the classroom palette here. You can, as further explore, there will be some other palette for slideshows, for the color, for the chart element. There are some other things. But most convenient one would be under the classroom assistant. Okay, you can always open it and leave it on the right-hand side while you are working on your screen. Right? This is for the assistant palette. And the help. Okay. What I'm conclude right now is something that you, if you have problems later on, you know where to find the solutions. So for this plot, for this help, using a question mark is quite handy. So for instance, if I know there's something about a plot I'm looking for, maybe a control plot, or maybe certain other plotting, but I cannot remember the name. So I can just put a question mark and then key in a plot, and then shift enter, run it. It will give me the list of all the, it's not coming out. Oh, it is where it came out. No. Oh, this, okay, sorry. If I want to find functions that contain something called plot, I need to add the what we call, this is something special function visit to find out anything in front of plot and anything after the plot is all included. So I can find something like, or maybe I want to find something that have start with anything but end up with plot. Then I put a question mark, something like that. I put enter, then I call out all the available functions, end up with plot. Okay, this is all available, and any of it you can just click, you bring us to the documentations. Or if I want to find anything and start with plot but end up with anything, so I can put the extract at the back there, then you plot, plot 3D, plot 3 matrix, all those came out. Okay, if I know that this is the function, exact function name plot I'm looking for, but I want to find out how to use this one, I put a question mark, and then with the name plot, you show me the summary of this function. Is how it looks like, plot with the functions, with the x range, and it could be with the list for the function, list for the variable, all those available for this plot. But normally we don't use this anymore because we straight away go to documentation will be much more comprehensive. But this one is also quite handy. It still is using so that you can straight away find out the function that we're looking for. All right, those are some of the built-in automation and helps to make our work much more easier. Next, I want to show you is something more advanced, so that you want to build your algorithm bigger and bigger, how to further go on it, which is using something called assignments and also the delay assignment with functions. Okay, first, you already know that we use double equal sign for formulas. So single equal sign is to assign a value. So when I say A is equal to this one, I run it, A got a value of 12. So A become black color. Okay. B, I run it again, B become 18, B become black color. So now I got 2 with the power of A plus 3 with the power of B. Of course, automatically you input the A, replace the A with 12, B with 18 to calculate the whole thing. But with this, we actually have do it in 3 different cells. Okay, and we also got 3 different output before we come to the final result we're looking for. But we can combine the whole thing with using something called semicolon. You combine all the things into a single cell. How to do this? We just put the cell, put the computation inside one cell, but separate with the semicolon. So this is the first calculation. You calculate this one, but using a semicolon means you don't need to show me the output. You calculate this one, okay, stop, and then you calculate this one, and put a semicolon. You calculate, stop, and lastly you calculate this one. Okay. This is 3 steps all inside one single cell. Last one, I didn't put the semicolon because I want it to show me the output. With the semicolon, it won't show. Without the semicolon, it show me output. So with this one, I run it, it straight away get me this output. Okay, similar with this, but everything inside single cell, which is much more easy and concise. Compare you write a very long thing, but maybe you don't need to display so many intermediate. And even if you don't want to display this one, maybe you have a C equal to this last output and you don't want to see this one, you can put the semicolon at the very last and you run it. It won't show anything, but it have a value of C. So right now, if I put C, enter, it will show me the value of C. Okay, but here it won't show because I put a semicolon. Right? Remember, after I define this thing, I can check back what is the value of the definition. I put a question mark, B. You show me, oh, B have a value of 18. Okay, I have a question mark for the C. C have a value of this. So if I don't want to use this anymore, I need to use a function clear to remove all the definitions. Okay, after I put clear, you can see the A, B, and C turn back into blue color. Okay, this is important because we might use repeatedly for other computation with the same symbol. If you don't want to use it anymore, you probably want to clear it. Okay, is to define a functions with the values, and then for engineering, maybe this is also important, working with Unix. For other people, maybe it's not that much, but I still want to show you that in Wolfram Mathematica, these built-in functions, or we call a free-form input, they have another function called a control equal inline freeform input. So it could be inside certain part of the whole cell rather than the whole cell is a natural input. Just now, you still remember if we start with the equal sign, the whole cell is a natural input. But if we using this one is using control plus equal, is only limit to that particular bracket. So this is a small bracket or small square inside here is computable. So with this one, you actually know the information. Let's say this is the example I use, 20 cc. Let's say if this one I enter, you actually send this one to the server and you find out what is this cc. You automatic convert and understand this is centimeter cube, okay, cm cube or CMC. If this is right, I can just accept. So this value is no longer a 20, but in fact, it carry a information of the unit. So this is important because Mathematica can automatically change whatever unit you put in. You can do the computation, mix and match everything. You still know how to do it as long as we key accordingly. Okay, we can key 20 milliliter, 20 minutes. You know this is minutes. And for that, we do computations. Okay, for this one, let me control equal 12 feet, have it, and 12 feet plus control 5.5 m. I didn't say in meter, I just put m. It would know. Of course, you can double check this one, see whether it interpret correctly. So this is, if I put my mouse over it, it show me unit is equal to meters. So this is correct. So if it is correct, I enter, it automatically calculate and give me a output. Of course, the output right now is feet. Okay, you can change it to what you want. You can convert a unit, okay, or display a unit as. So I want to convert the unit. Convert to which unit? Convert. You can key in new unit here. My unit I want it to be in mm. Okay. It automatically convert to me 9,157.6 mm. Not only for some measurement unit, but it can be anything. Okay, even in the currency. If we try with this exercise together, calculate 10 meter per second times 5 minutes with unit. So how do we do this? We use a control equal, okay, 10 meter per second. Of course, if you do this in other software, they probably just know m over s, but they don't know m is meter, they don't know s is second. You still can do a calculation, but they don't really have the meaning of it. It just have a symbol only. But this one, they actually know what is this. So if I times equal, control equal, it should be multiplied by 5 minutes. And then I shift enter. It give me the answer, 3,000 meter. And if let's say example, ringgit Malaysia, 32 ringgit Malaysia minus 5 USD, US dollar. So how much is that one? How do you know ringgit, let's say ringgit Malaysia? So you understand just now and why. Let's try that. Okay, this one, yes, Malaysia ringgit minus the USD5. Okay, correct. So if I shift enter, you calculate based on the current rate, last available current today's rate, based maybe from a Google Finance or Yahoo Finance, there you get the informations and convert together. So this output is in the 2.47 USD. And of course, I can convert the unit. If I want it to ringgit Malaysia. So it's 10 ringgit, 57 cents. Okay, you can try this whether the conversion is correct. The rating is it by today. Okay. So this is very handy. So your computations, you don't need to worry too much about a unique thing. As long as you key in accordingly, the output should be all right. Right? Okay. Import and export. Okay, there's a question. After pressing the equal sign and type, are you pressing enter before entering the next? You don't really need to enter because after you key in, you wait for a while because it's sending the information back and forth, and then you automatically appear with a check mark. Okay, you can enter it, but I think we are used to finish everything we enter. I think it's okay, doesn't matter. But if you don't enter, you also automatically change. All right. For the import and export, I think we're doing a lot of data import and export. So I quickly go through this one so that we can finish on time. Import, I can import something from the website directly. Okay, this is the default website link with the data. I want to import, I just use a function called import, put in a URL, and then comma say this thing import is data. Okay, it's not picture, it's not any other audio file. I want this data file. And I give the whole thing that I import with a name called data1. So if I run this one, you access to the website and download the thing. So this is a list of data with the first name, last name, and their score. First name, last name, score. Okay, this is 5 sets of data. The data right now, I give a name called data1. So with that, I actually can play around, or you already know how to play around with the part. Part is called the data element from the data1. So from the data1, I want to call out the first element. The first element is now this one. So if I run this one, this is the first element. And part, you can use it this way, or you can write it this way. It's also the same thing. So how to write this one? You use a name of the data, and then you open the shorthand. This is called shorthand. Double open square bracket and double close bracket. So open square bracket 2 times, close bracket 2 times, and then which elements, let's say second element I want to call, I run it. So this is the second element, James Smith 85. James Smith 85. So this is the second element from the data. Right? So first element, or using this short form is much more easy to write. So I can say data, I want it to run from the third to the -1. -1 is the last one. This is semicolon, semicolon here. It means that from here to here. So from 3 to the last one. Okay. And then this is the row. Okay. All the row. And then this is a column, the column. So this is what you get. 82, 83, and 98. 82, 83, and 98. Okay. That means from the third row to the last row. Okay, this is third row, fourth row, fifth row. Last column is 82, 83, and 98. So this is how it means. Last column. This is row, comma, column. Means X, Y. Okay, this is how it looks like. So work example, try to sum up and find out the average score for data 1. Okay, I just give you the answer. For data 1, to find out the average, so I use a mean data 1. Data 1, you see, after I click data 1 automatically appear in the drop down here because they already recorded data 1 have the definition of this information inside. So I click mean for this data 1. I want the score. So the score is part 1, part out. So you still remember just now the example. I want the X, how many row? All the row. So I click all. Instead of I put 1 to -1, I can put all. All row, which column? Third column. Third column is for the score. First column is your first name, second column, last name, third column is score. So I want to get the mean for all the score. This is how I get. So this is the mean. Then I want to sum it up. This is a main. I want it to be in numerical output. So instead of create this one with the numerical output, I can add the n at the top, at the front. So n is for numerical output. So this is the average score for all the 5 people. The 8.4 is average. All right. This is how actually we can easily import and export. I will show you more example in import export. But now we try to show you what is the working directory. This is important when you want to deal with your data in your directory. In Wolfram Mathematica, when you want to import something from external directory, you don't really need to fill in the whole file part, maybe C drive, blah, 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 the whole thing until you export. You can just import, let's say I got a file name with a data called desmond.txt or desmond.excel file. This is a file name. I just need to key in the name for the Excel file, and then Wolfram will automatically look for this file name inside the specific directory. Which directory? The working directory, where I'm working right now. So you don't need to fill in the whole file path. So how do I know which directory I'm dealing with? You just type in directory with a bracket, and then you run it. You say, okay, right now I'm working with this directory, users, text. This is my directory right now. And also, I want to find out my notebook directory. Notebook directory is currently my notebook. This notebook right now, where is my notebook at? Is notebook directory. It's called notebook directory. So if I click on this one, oh, my notebook is under my OneDrive and my desktop. Okay, this notebook I open from my desktop. So my current notebook directory is different with the directory, the working directory. Okay, working directory is when I import export, you first go to the working directory. It's not going to notebook directory, but it goes to the working directory. So in that case, I want to make sure that my working directory, I want it to be similar with my current notebook. So if I got the export file or import file inside, running inside this notebook, I want them all together put under the same folder or same directory, so that I can set my current notebook directory, where my current notebook is, become my working directory. So this is how you do. Set the directory to my notebook directory. So my working directory is similar with my notebook, where my notebook is. So currently, my notebook directory is now become desktop. So if I go back to this one directory again, I check. You so, oh, now your current working directory is desktop. Okay, you run this thing to make sure everything is similar with your notebook location, so that after I put the import export, it always look for that one. Alternatively, I also built something like this called set directory. This functions. This function is much more user-friendly because after you click on it, it just appears with this pop-out windows that we can straight away to select which directory you click, choose, then that one become your working directory. Okay, this is much more, I think, familiar to most people. But unfortunately, this function is not available for the Wolfram Cloud. Okay, it's only available in the desktop versions, because desktop version you can apply with that one. Cloud is not available. Okay, if you're using cloud, you just ignore these sections. So try an example. Why we want to do this is because just now we download the data one. We already got the data one. Now we want to export. So because I already set my working directory, when I say, okay, you export all this data one inside a file name called data one. You create this file name, data one.xlxx. Okay, put this data inside this file, and this file where to export, I don't need to tell, because you automatically go to my working directory, which is my desktop. Okay, because I already set. So I don't need to worry to search, hey, where is my export file? It's already there. Okay, you can always go, it already done the export. If you want, you click on this one, you see the suggestion bar, say open, import, open file directory. I can just click open. If I click open, it automatically apply the function called system open. You open this XLXX file with the relevant software. Of course, this will be the Excel file. So now it's open up with the Excel. Okay. So this is Excel. So we export, it becomes the file called data1.xxxx. Okay. This is already exported. So it's not only I export data, I can also export picture. Let's say what I want to export, this is a file name I want to create. I want to export to a file called image.png. But what will be the thing that I want to export is I want to export a plot 2D, a plot sin X. Put the whole thing, become a image file called image.png, and export it to my working directory. This is how it works. So let's try. Click on this one, enter. Now it becomes an image file. And I click open it. Okay. Now I open. It's become a PNG. So I already export inside this file. Sin X. So this is how we export it. And of course, you can also export different data. Let's say I want to export data to another file, but with 2 layers, A1, B, 1A, 2B, 3C. I can manually key in my data and I open it. Is how actually I can export inside here, right? And also, of course, I can say import. You see, after I export the file called data2, I can say import it. I don't need to tell which file part to find it. Straight away, it knows to find it from working directory. And then what kind of data to import? I say it's data to import. And this one, you can refer to this one. I put in the note here, is the file type, sheet number 1, which row, or the row I want, which column, second column. So I can always import back by using this format from the data tool. I'll import the second column A, B, C. Okay. Similarly, I can use this one for the export. Okay, export this one to a which file, right? Okay, I got how many page more? 2, 3 pages. I probably won't be able to finish one. Let me quickly go through these defining functions so that I can let you go on time. After this one, I will give you the certificate link for you to get a certificate. And the last part, if you got time, we'll go through with you. If you want to leave earlier, it's fine. I will post the recording later on if you want to. Just write to us or WhatsApp to us later tomorrow. Okay. For defining functions is so that the functions have a definition that can be repeating using later on. So this is how we define a function. I give a name of this function called f. Okay, and then it have a x underscore. X underscore, like what you say here, is mean anything. Anything, x can be anything. So fx have a definition of x squared plus 5x. And start with this column equal sign called delay assignment. Okay, I'm not going to the definition of delay assignment, but this is how we define a function that can be repeating using. So once I define this one, my f functions now have a definition of what? If I put a question mark f, you know that it's x squared plus 5x. Okay, so later on, if I put anything to replace the x, it automatically apply to the right hand side here, x squared plus 5x. So if I put a 4 here, you know that is the 4 squared, 16 plus the 5 times 4, 20, so it'll be 36. So if this thing not a value, but is instead is a symbol, you also know it will be pi squared plus 5 pi. And it could be multiple things. It could be under a list of different elements. there'll be three elements inside here. So the x can be three different things. 1.323, 3 pi, and 5. So you run it, you got three output. Okay, this for first one, second element, the third element. And it can be also like this. If I have function a squared plus 1, so the whole thing become replaced with this. Okay, is how you can depicting using as a function that you probably already create something you want to use later on. Your function, this one of course is a very simple function, is one single line. A more complicated one, the function could be multiple page, multiple line that you want to use it later on, carry on and on. Okay, of course, after that, you don't want to use, you just clear the f. So the function f name is release. This is another example. If I want to create a function called my function myf, this function x underscore, say colon equal, I give a if then else condition. If the x, when I key in here, is larger than pi, then it's true, you print. Print means display the output. Print x, print this number or this value, follow with the text. This double quote is text inside is larger than pi. If it's not larger than this one, then if it's false, you print this one. Okay, so let me run this one. So this is my function. So if I key in a value e here, you automatically run the right-hand side function. So if e is larger than pi, then you print this one. Seeing that e is larger than pi, so you print e, and then follow is not larger than pi. See, it can be easily done. So if I put 2 here, I run it, it says 2 is not larger than pi. If I put 5, pi is larger than pi. So you can create something like that to repeating using. Okay. For this interactive model, I have to go through very fast. Oh, okay, so that you can go through later on by yourself with self-explanatory on this, how to manipulate using. Normally, we can bring a output like plot, you already learned this one, but to make it interpolate, we can add something called manipulate. Add in a manipulate, what is the difference between this function and initial function is we add in a variable. You double check with these two lines. What difference is instead of 5x here, okay, I change the 5 to a. So the a, it can be anything. Everything up to here is the same with the plot. Just that I add a manipulate and then I put a comma, say the a, I give a range, -2 to 20. With that, it become a extra options or a slider with a range of, I give it from -2 to 20. So it got a range of -2 to 20. So you can actually slide the whole thing to play around. By using this, we call the super function in Mathematica manipulate, adding the variable. Same thing, same concept, you can apply to this function with multiple controller or multiple variable. This is only one a. We can add much more. For example, the 8 plus 1, I think I just give you the answer so that you can copy this one and try it later on to experience it yourself. Plot sine x, the x in front, I got an n. Okay, n is a variable, and then I got the x with a range from 0 to 2 pi. Okay, and then outside this manipulate, I want to have the n with a range from -5 to 5. Okay. Right. So you can have something like this. I put this in the chat room, so you can just cut and paste if you want to. Okay. Helen is having a surprise emoji. Okay. It's almost there. We're almost there. Okay. And this one is creating a manipulate. But you can see one thing about this thing is the visual output here, it will automatically make the visual as a best view. So you see the scale on the y-axis is 1 all the way, but when I move here, you want to display the best view, so the range from the Y will be changed. So for that, sometimes for these visualizations, we don't want this to change. So we want to add in something called plot range. I want to fix the range so that it won't change. How to do this? Just the same thing. I copy. I just need to add in the plot range for this plot. So after the plot here, I just fill in the plot range. The plot range is after the I plot range. The plot range with this, I say I want it to be instead of 1.0 and then frustrated, I want it to fix it 1.1. So the max is 1.1. So whenever you move it, you always fix the Y to the 1.1. It won't run away. So this is a range functions to control the view of the visual. All right. So I copy this one and put in the chat room as well. So you can paste it. Okay. And there are multiple controller it can be added. This one, I think I already straight away do it for you. You can just run this one. It's just expanding much more. Say, rather than just sign, I replace it by a name variable called functions, fn. The fn, so this is the, instead of sign, I put fn. Fn is what? Fn can have this sine, cosine, tangent, secant, all those things inside there. So it becomes one of the variables, fn. And I also, this, instead of n, I put frequency, fq. So they have a range of 1 to 5. ph, I add in a phrase. So the phrase have a 1 to 10. The rest is I add the tickers, add those options under a plot. I want to add the plot style so the line become thicker and dash line and red color. So if I run this one, this is how it looks like. Okay, frequency, and then you can change the different functions. Okay, this is how it looks like. And also, how about if I don't want this to appear as FQ or PH, I can also define the names to appear here, and also together with the initial value. Whenever I run this one, what is the initial value instead of always 1? Okay, this is how we, the next step. Okay, Fn here, the function, I put a function, add another layer of curly bracket. I say, I want it to appear as the name called functions in the visual output. So this is a name. And then this one is the initial value. So it always start with the 10. I don't want it to start with sine or cosine. I want it to start with tangent. Okay. For the FP here, I want it to have appear with a name called phase. Initial value is 1. FQ here, the frequency is the name to appear. Initial value is 3. So if I run this one, this is how it looks like. So you got the initial value for the frequency, 3, and you have a function tangent. Okay. It is some basic controlling of the manipulate, but you also can use it for other things. Instead of visual, you can be calculation as well. Okay. It's 5:10 now. I give you a certificate. Then later on, I need another 5 to 10 minutes for those who can stay, so to complete the some other extra thing about the demonstrations project here. Is all the ready project that people or user Wolfram Mathematica or even a Wolfram's staff itself created with the with the manipulate. So all those things are interactive in this website. If you click on the link here called demonstration, we have 13,000 it keep on adding a new project inside here. All those interactive things are created with the manipulate. It have different topics. You can always go and tap here and see the topic you want, or you can come to here, even like a simple from a high school math to the more advanced quantum theory. All those things is inside here with all those manipulate. Why is it important? Is it, for example, if I click on this one, a simple thing, right? This thing is available on the website itself. If whether you got license or Mathematica or not, it doesn't matter. You can interactive and click on it to see how the thing interact and change on the visual output. Okay. The first time probably take a while to run it. After that, you can see if I click on angle of depression and sign. This is something maybe for high school math. And how actually this is something created by the Wolfram Mathematica user using the coding. And if you want to see how they create this one, you can click on the source code. Okay, you can click on the source code, you download the whole file, or you can copy the resource object. Let me click on copy the object. Copy the object. If I come to my file, I open a new file and just right click and paste it. I'll copy on this one. Copy, manipulate to clipboard. Okay, okay, copy to clipboard. Just ignore this one, and then I just paste it here. Yes, so you can copy the whole thing and it becomes something that you can make use in your project. Or if you are the presenter, maybe you want to explain some Newton theory. Maybe you want to explain thermodynamic things. They are available visualizations here with the charting, with the dynamic thing. You can just copy and paste and add in. Even if you are preparing an exam paper, you can have this thing inside your exam paper. It won't show the coding. If you just copy the visual, you just spray it down. Probably your question is, after you change this angle, what would be, why the output would be like this? Please explain, or something like that. You can have this in your questions. That is what we do a lot in the exam paper for a lot of other university as well. And if you want to see the coding source code, you can click and download the whole source notebook. Okay, you download the whole source code is because you can actually access the coding they create with the manipulate. With that, you can further improve yourself how to write a coding similar to this, or maybe you have something like that. Okay, let me click manipulate. You see, this is how the coding. They also start with the manipulate and add in some graphics and visual symbol and computation with the text style, all those things. So this is the coding here. Couple line, maybe about 15 line, then get your output. So with that, you can also improve and check how to further build on this. You can explore. There are 13,000 of it. You can see the topic available. The topic in mathematics, high school mathematics, physics, science, life science, business, all those are available. I leave it to you for explore. Okay, next, resources. This is for you to explore. There are a lot of training videos available. Okay, demonstration project I showed you just now, and the Wolfram Alpha link that you have just now. And some license. If you or your colleague or friends haven't get a license from these three universities, they are available to click to get it from here. And one last thing, I didn't show it here because most of you probably don't have the license of the ChatGPT plus API account. In fact, if you have the account, you can have something called inside the Wolfram Mathematica here with something called the LLM in Wolfram Mathematica. Or you check on the documentation, you can see LLM is already available in Wolfram Mathematica since last two versions, a few versions ago. So with this, you can always click in and ask some Wolfram this LLM to solve the things for me, so for us. For instance, maybe let's say go to example. For those that want to, let me see. Just get a simple one. Let's say I copy this one. I go to my, this we call it file new, this called check enable notebook. Check enable is built in with the persona or LLM. This is called Woofy. You can just key in like the ChatGPT here, but this everything inside the Wolfram Mathematica. You say make a table or list of digits for the first 10 square. If you have the ChatGPT API account, you can link to your Wolfram here and then straight away activate it. Okay. Right now, they are OpenAI credit is not built in inside here. You have to pay for OpenAI for the subscription of API. But in the future, I heard that Wolfram have the planning to include some credit inside Wolfram Mathematica so that every user can make use of this in a certain degree, maybe some free credit for the first few couple use in one day or what. Oh, somehow my API key is not sure what happened. Sorry about that. But if you have the API key connected, those things, the coding just now, you actually came out for us. Less worry, and I try a lot, and unless it's very complicated, else I think the output of the coding is quite reasonable, and I think sometimes it saves a lot of time, especially for a beginner. I think you just type what you want, it gives you the code. How amazing is that? All right, but so far, not so many people have the API credit, so I didn't show how to set up. But if you are interested, come to the documentations, find out the LLM, machine learning and LLM, and how to set up large language model here. All right. 20 minutes overshoot. With that, I thank you for your time. Let me see if you get any question. Otherwise, you are free to dismiss yourselves. And hopefully I can see you in the future as well. If you are from certain faculty that you think you want to invite us to give another topics on the training, maybe even a physical training, come to your faculty, let us know. We can try to arrange it for you. Okay, whether it's free or pay, we can discuss on that. But normally we don't really charge much. Only maybe we just charge for the accommodations or maybe the traveling fee. The rest, we don't really make money from this. Try to make this available to everyone. So if you are faculty in the Klang Valley, you want to make any training, let us know. Come to us. All right. With that, I thank you everyone. And I see there's a question from Umar. It says, I want to solve ODE. Can I follow the same procedures? Which procedures? Sorry, I missed out. But ODE, yes, you can also check on the documentations. There are a lot of I think ODE is quite mature here already. You can find out the options here, and also but Wolfram Alpha, I don't think you can solve because it's a bit complex. LLM, maybe you can try because I haven't tried that one, but you can start with the documentation here. And also the Wolfram U, which is Wolfram University. They had a lot of training topics available and they're quite updated with all the courses. So I would suggest you come to this Wolfram U to look for the topics you like to, because today is more on the beginner level. If you want to go for more your areas, expert area or domain area that you're interested, come to here and look for that. A lot of interactive training as well. Right? And some of them give certificate free. Right? Okay, Umar said, I mean use documentation. Yes, you're on it. Thank you so much. All right, with that, thank you and see you again in the future. Bye-bye.